All right, good morning. We are in week 4, day 4. This week you've been learning about classes in Python. And today we're going to kind of build upon what you learned about in last class, which is class inheritance. So last class, I looked back and you learned about having these two separate classes, but it's not very dry. We're doing a lot of the same thing in each one here. So you were able to create a base class, which the class is inherited from, just to kind of take care a lot of these attributes, the defining of these attributes, so we didn't have to keep doing it over and over again for our classes. So today we're going to kind of build upon that. And I mean, you learned the basic employee. You can just, in order to initialize them, you would call super in the init method of which would be called in the subclass, but it calls from the parent class init method, which we'll kind of go into a little bit more here in a second. But today we're going to cover multiple inheritance. So subclasses aren't limited to only inheriting from one parent class. You can also inherit multiple characteristics and behaviors from more than one parent class. So we're gonna be speeding through this README, but after this, we're gonna be working on a problem and working through this on our own. But in this example, we have our class fruit and we have a class pie. And then here we have a class that inherits from both of these. And it inherits from fruit and pie. And it's kind of set up the same way as you saw inheritance before, where in your init method, you're going to list all the attributes you're going to be passing into this class. And then you call your super init, which pulls down the attributes from the parent classes. So when this is defined, we pass in fruit and pie for it to inherit in here. So in the last class, you saw you could do just from one, but here we're just going to string them together using a comma to separate them. And then we define this init method. We want to name, plant, and ingredients. As we see above, name and plant and name and ingredients have already been defined in these parent classes for in the initialization. So we don't have to do this again. We don't have to type self dot name, self dot, and we're just going to call a super init, which takes care of all that instead of having to go through and define it again. So if this whole super init is confusing with all these attributes and parameters being passed down, all it is doing is making it so you don't have to define it again like this in the subclass. So it's taking out all that work so we don't have to do self.name equals name, self.plant equals plant, because it's already taking care of that in these parent classes. Okay, any questions on that little overview?
Are you going to do like an example to see how they come out? Because utilizing those variables in methods you're creating in the child class, that still got me confused because you don't still say self dot plant, do you? Within um the fruit class? No, the fruit pie, sorry, the fruit pie class.
So, okay, you want
If
to
you're
look
making
at
a method
like,
within it.
we want to look at like setting up, here, we can copied it. Okay, I'm gonna do it up here, not in the console. So we learned how to initialize the last few class or lectures, correct? So if
Yes.
I want to initialize a fruit pie, how can I do that here?
You would just say cherry pie equals fruit pie.
No, we're in Python. Let me do this. Cherry pie equals
Fruit pie parentheses, and then you would say name, I don't know, Sean, and then plant would be cherry, I guess. Ingredient would be flour. And then if you wanted to make a method within fruit pie to use the variables within its superclasses, the parent classes, do you still have to do self dot plant?
Oh, so you're talking about if I wanted to make a
Yeah.
name under here. Yes, anytime you want to refer, we're not going to anything within this class, you have to call self because it's saying within myself here.
Even though the originator isn't the fruit pie class, the originator is the pie class.
Correct.
Okay.
All we're doing from these other classes is we're just taking this structure. We're not taking anything defined and like we're not taking a value from the other class. Um, I don't know if that makes sense, but we're taking the structure. So, like I said, the only difference by calling a super init is I don't have to go through and do this self dot setting up all the attributes initially.
Okay, because it pulls all that data down into the class.
Yes.
Okay.
Because what this is doing is it's saying, okay, initialize these within from these parent classes. So we could see name and it will, this is called the method resolution order. But within classes, Python will first look within the class it's in. Um, and if we don't have a self.name equals name in here, which we don't, and then it's going to go through this super init and it will use the first class you've listed here, the fruit. So it says, okay, I'm looking for a self.name somewhere, trying to see where this, how this is initialized. So it's going to jump up to the fruit class and look in here and see, oh, okay, self.name equals name. Well, I have a name here, so I know now that my self.name equals name. Anything I pass in. Does that make a little more sense?
Yeah, that clears it up for me.
Okay. Any other questions about that? And we're going to do some defining methods because I know the last few classes y'all have really focused on the attributes passing between the classes, but there hasn't really been a lot of talk about how the methods pass from the parent class to the subclasses. So that's what we're going to dive into a little more today, but just trying to give a little brief example here on how we can inherit from two.
Tiffany, can I ask a question here? And maybe this doesn't pertain right now, but I just noticed ingredients is plural. Is there a way, can that be a list or if you wanted it to be,
Yeah.
or a dictionary or something? Okay.
So, I mean, yeah, you can pass in a list and it will, and during my example, I'll show you how we're going to define an attribute to a type, a specific type. But, okay, any other questions initially on how we are inheriting from two classes here? And again, like what this does is it looks within here first, within this class. If it doesn't see it here, it's going to go to the first one. So it'll come up to fruit and look in here. And it found name and plant, so it'll initialize using this structure. And then it looks for ingredients. So it looks in fruit first. Well, it looks in fruit pie, not here, goes up to fruit. There's nothing about ingredients here. Then it goes to the next one, pie. And it looks in here. It sees ingredients is initialized like this. So it uses the structure for its own class. Okay. This is all going to be a little whirlwind right now, but we're going to step it down a bit when we go into the example.
I guess I have a quick question.
Mhm.
So since there's two names in each of them, how does it know which one to pull the name from?
With that resolution, it's called method, MRO, method resolution order. It's MRO for short. It will always, it goes in order. It's going to start within the class it's in, and then, oh gosh, I'm in a next one here. So you said within the two names, where does it know to look? It goes through each step in this hierarchy. So it's going to start within its own class, then it's going to step through each of these classes in order
Okay, thanks.
to find the information. So we will see in a little bit how this can get tricky. So we're going to step now into multi-level inheritance. Not going to spend too much time on this, but this shows you how you can inherit from multiple, you'll have a parent class and then a subclass here, and then this next class inherits from both this subclass and the parent class, just kind of waterfall trickling down. Like it says here, it's good for creating like a hierarchy, like an employee hierarchy, so we can have like employee, supervisor, manager, director, and just pass down throughout the classes. So here with this, we have family, genus, and species. We have a family name identified up here. The genus will get a family name, but also the genus name. And the species, which inherits from genus, has access to everything within family or within this genus, but also everything within family because it's inheriting down the line here. Any questions on this? No. Okay. So here is where we're going to get into a little bit more fun. And as we can see, we finally have some methods within here. So we're going to copy this. We can use both multiple inheritance and multi-level simultaneously. So this allows the subclass to inherit attributes and methods from two different parent classes that each inherit from a single base class. So we're going to look at this within code. Okay, so here we have Rockstar. This is our base class. We have an init method where we pass in a name. So our Rockstar gets a name. And then our Rockstar can also rock out. And it'll print out this little hand emoji. Vocalist, we see vocalist and guitar are both inheriting from Rockstar. So they also have name. We've done a super init, so we don't have to sit here and say self.name again because Rockstar already did that. But we're also giving the vocalist a mic and the Rockstar or the guitarist a guitar. So these are two new attributes that we are adding to these classes that make it different from Rockstar. And because we've added something new, we have to initialize it here. So we say self.mic equals mic, because there's nowhere in here that says self.mic equals mic. So we have to do it here. These also get their own methods called rockout. And this one will print out a microphone, and this one will print out a guitar. So right away here, before we get into the backing guitar, which has both, let's define a vocalist and a guitarist. So, oh gosh, okay, I'm horrible with names. Somebody give me a vocalist we can put down here. Random name. Who was that? I didn't hear.
Is it Paparazzi, the orchestra guy or the opera guy? Is that it?
I don't even know how to spell that.
I don't even.
Let's do share. That's
Okay.
easy. Okay, so we'll define our new class like this. Share is going to be a vocalist, and we see within the initialization method here that we expect a name, and we can pass in a mic, but we don't have to because we've assigned a default value. So if I leave it out of this, it'll automatically get an empty string. This, I don't know what they intended to do here with these. Maybe pass in a little emoji as well. I'm not sure. But we'll give her the name share, of course. Okay, so if I call share.rockout, what do we expect to see?
The emoji.
An emoji? Which emoji am I going to see?
Well, it's the vocalist, so you see the little microphone emoji because yeah, you're calling the rock out method, so it should print out to the console microphone if the console can do that. Okay, okay. All right, it prints a microphone. And this is because when we call rock out, it's going to go to its own class first, which is vocalist, and look in here and see, do I have a rock out method? I do. I do have a rock out method, so I'm going to print this out. If it didn't have a rock out method, if this was gone, now what do we expect it to do?
Turn out the hand emoji one.
Yep, it should print out the hand because it's going to look in here, not see it, and then go to its parent here, which is Rockstar, and find a rock out. And it'll print this. Save it. Oh, wait, did I not save it? There we go. Awesome. So this shows you that if you have a method in this subclass that is named the exact same thing as something in the parent class, this will overwrite and be the method used. Okay, so with guitarist, same thing. We define a guitarist and then call rock out. It will use this guitar emoji and print that out. If it didn't have that, it would look back in Rockstar and use that rock out method. So this can be useful in some situations. But what happens down here? We have a backing guitarist, which inherits from both vocalist and guitarist. Here we see we're again doing a super init with the name because this is the only thing shared between these two classes. And then we are calling a mic and a guitar with default values. Does anybody know why I can't just do a super init with all of it, with mic and guitar?
Because they're two different subclasses.
Yep, so sorry, I'm trying to click on some things over here. So it is two different subclasses, but if I'm inheriting from both subclasses, I feel like I should get a mic and guitar then, because I'm calling both these subclasses, or inheriting from both these classes. So why do I not get that? Now I'm going to tell you. It's because with when you do a super init, this super can only take from one class. So this super is going to take from the first one in the list here and initialize from this class. So if we're passing in super init name and mic, and it goes to vocalist, okay, name and mic, we're good there. It has a definition here for how to initialize name and mic. But if I'm passing guitar and I go into vocalist, there's no guitar. It's not initialized within this class. Unfortunately, the super init is not going to just automatically go to guitarist next. It's going to stop with just this vocalist class for initialization. We could do something like vocalist dot init and pass in name and mic. And then we can come down to the next line and do guitarist and explicitly define if we want. And that will tell then, instead of doing a super, by explicitly calling each of these classes, it'll tell this class where to look to get these initialization methods. Okay, but to keep it easy, we're not going to do that. We're going to keep our super just going to vocalist, and instead we're just going to go ahead and initialize within this subclass itself.
So if you had like something like vocalist, if it had a bunch of different instance variables, it might be and same thing with guitarist, it might be a better route to go, like you were just saying.
Yes, yeah, it probably would be in that case. If you wanted to take all those attributes, definitely if you had a really long list of stuff to pass through. But and it's not that much more work. Like I said, you just call the class instead of doing a super in it, you'll do a class in it. So basically what it's doing is looking for that class, finding its init method, and calling the initialization that way. This can be preferable though sometimes because this gives us a little more, what do I want to say, like personalization with this class, because we can set our own default values here then instead of getting the default values from the parent class. That makes sense. Because the parent class has a mic set to empty, but here we could give it, I don't know how to do, we could give it our own value here. So I think that's why we're doing it this way here instead of inheriting all attributes. But we are going to move on now to, so within this, we're going to create our backup vocal or backing guitarist. Ooh, I definitely don't know backing guitarist names. Nobody else? His name on Bob. And nice little handy thing in VS Code, it shows us all the attributes this class is expecting to get in, including if there is a default assigned to it. So slash, yes. Okay. I like that. But I'm not going to capitalize because it's a variable. So the backing guitarist, we are passing in a name, like it says in the init, so slash. And mic and guitar have default values, so I'm actually not going to pass them in right now. Now, because this class inherits from both of these classes, I can call rock out, right? I should be able to access all methods within the parent classes. I should be able to call rock out. What am I going to get?
I'm gonna get the vocalist one because it's the first one in the set. So the microphone.
That's what I'm thinking.
Correct. We get the microphone, but I wanted the guitar. So that's a problem because the guitarist is not the first one in this list. We could switch it around. I could put guitars first, but maybe next time I want rock out to print microphone. So how can I fix this?
Have
problem.
to rename the methods.
Yep. Yep. I would rename the methods. So we can probably call this, what is the, I know the lecture has names. Okay, sing verse. They changed it to sing verse and guitar solo. So we'll do that too. We will call this sing verse and guitar solo. So now we have much better control about which method we're calling here. And we can still call rock out. Should give us the hand then, the rock hand, because that is the only rock out we have within these. So sometimes it's good to overwrite a method, but other times if you want that flexibility to be able to use both within your subclass, then just finding different names, naming everything uniquely will go a long way. Let's do this. Rock out gives us the hand.
Rock out is not a parent class anymore. Like, how did that happen?
Rock out. Okay, so we're inheriting from vocalist and guitarist. Which,
Oh, and they're inheriting from Rockstar. It's a chain going. Okay.
yes, yeah, you can inherit like millions of classes if you want. String them all together. Wouldn't recommend it, but yeah, it's just the hierarchy. So we're gonna do our guitars. Just for example and showing, yes, now we get both of them. We have our rock out and our guitar. Okay, any questions on inheriting from multiple classes and how it works to access these different methods within the classes? Nothing right now? Okay, good. I was hoping this would go quickly because we're going to work on creating our own class now with all the knowledge we have just learned. Let me make sure that was all that we had in the lecture. Yep, that was it for lecture. But I'm not satisfied with just that. That's not a lot of information. Okay, so we are going to walk through creating a class together now, and it's going to be a little involved, but a little more applicable to what y'all are going to be using classes for. So right now we are setting up an online shopping platform. And I want to design a cart system and a checkout system. And we could just string together, like a whole bunch of statements, like a whole bunch of scripting, if else, that sort of thing to kind of make our cart system work. But we're going to want to change up discounts sometimes. We're going to have sales. We want to add in tax calculations that are like specific to people's regions. So we need to be able to have something that's flexible and can be reused across the board. So in this case, that is perfect for a class system because we can set up kind of a constructor on how we want all this to look, and then we'll be able to call these classes using different values in those attributes. So initially, like I said, we're making a cart and checkout system. And I'll share this code afterwards, but you could follow along too if you want to in VS Code. So I'll wait a few minutes here, or just a few seconds. So it's like when you go on Amazon and you add things to your cart. Up in the corner there, you have your cart, and then you click on it and you can see all your items in there, and then you'll have a checkout as well. So we're going to be making this. Okay, so first things first. What's the most basic thing I need for this? Where can we start? Anybody have any ideas?
We need to create a class.
Yes, we'll create a class. But let's think a little more abstractly here. What's like the most basic thing I need here in my cart and checkout system?
Putting in items.
Okay. So, yep, going in the right direction. Even more simple than that. I think I want a cart, right? We should probably have a cart to store all our stuff in. So we're gonna start creating just a basic cart. Let's just put in our init just to get that in there, but we're gonna do some more thinking before we. Okay. So what do we want to be able to do with this cart?
You want to be able to view the items that are in there and then eventually process for checkout. And then if we're not happy with an item, maybe we want the option to put it back on the shelf.
Okay, so I'm hearing just like a regular cart, we want to, I don't think, right now, we're not gonna do like a view cart thing. That could be, something later we could look at if we want, but I definitely heard like take out items. So on that too, we want to be able to add and remove items. Yep. Okay. These should probably be, should these be the same thing? If
No.
yeah, let's make them two different things. We're gonna have an add items, and we're gonna remove items. These are two different things we want to be able to do within this cart. Okay. And what else do we want to do? So we have putting items in, taking them out. When we want to go to checkout, so we'll want a checkout feature probably. What do we need for checkout? I'm looking for maybe one more thing here.
Will
Traceability.
cost
Yeah,
argument, or do we need? Yeah, okay.
yeah, I think we'll probably need a cost, like a total cost, because adding items and removing items, I don't think I'll have a cost thing with that. So yeah, that's a good idea. We'll get a total cost going here. Okay. So looking at it, I think this is a good start for a very basic cart. We just want to put stuff in, take stuff out, find the total cost of all those, and check out. Okay. Now, how do I want this cart to look? We're going to be putting items in it and taking items out. What kind of, I guess, what kind of data structure can we use for this cart? Do we want to initialize anything, or do we want to, oh, go ahead, does somebody have an idea?
We need item name, its cost, and how many.
Yeah, so I'm gonna put that down here so we could see. We won't probably want a name, cost, quantity, and a cost. Okay. So when I'm looking at this with multiple things,
You probably want a dictionary, right?
yeah, I think we'd want a dictionary. And do we want to pass, when we set up our cart, do we want to give it any attributes right away? Do we need it to have anything right away?
Like the owner or the shopper, or like identify whose it is?
Yeah, I guess we could. We could give it like an owner. or shopper. That would help in the future if you're trying to have an association between another class and this. For now, we'll keep it easy. I don't really care who the owner is. I just want an empty cart. So I'm going to say when we set up a cart, I don't need to pass anything into it. I just want it to be an empty dictionary right away. Okay. So I'm just going to have my cart is going to be an empty dictionary, just waiting for all of our items to go in there. And this is going to store. So in the dictionary, we need a name, quantity, and cost. Anybody have a suggestion how our key values should look within the dictionary?
It'd be like a nested dictionary, right? Key value name. I mean, key value, yeah, the name of the item.
Okay,
And
so
then the value of that is another dictionary with quantity, the name, and the cost? No, yeah.
okay, that we could do. I think that adds a little more complexity than we need here.
Okay.
So, any other suggestions? We could add a sub-dictionary, but we can also, let's just add a tuple. Don't use tuples much, but we can use one here. So we can put in our dictionary and each key will be the name of the item. And the value will be a tuple of quantity and price. Okay. Does anybody know, before we get into, well, we'll come right down into this. So does this look good? If I initialize a cart, I'm going to just have an empty dictionary. Looks good. Okay. Let's move on to add items now. So we'll make a method here, add items. Always put self, just make it second nature. That's the first thing you're going to always throw in here. And does anybody know what this self kind of is? What this is doing?
It's referring to the class like itself.
So remember a while back, I was kind of telling you the difference between methods and functions. Methods you do not have to pass anything into, and it's because of this right here. By saying self, it's referring to anything that's initialized within this class. So the Python list is a class, and when you call a method on it, it just automatically knows, because of how it was initialized, that all the values you are passing in are in that list. So here, if we say self, it knows it's going to look at all the values within this dictionary when it was initialized. So we don't have to explicitly say anything else about that cart. It's already there. It just knows, it knows automatically to look in there. Okay, so, and we're going to, if we're going to add an item, we'll probably need to add in probably the name of it and the quantity and the cost. Okay. Do we want any default values, or are we good just as is? What happens if somebody just throws something in there and doesn't specify a quantity or cost?
This default one would be good.
Yeah, I think so. For quantity, we think.
Yeah, I think so.
Yeah, so then we're thinking ahead that if we just call add items, it can maybe just throw in one of the item each time. It's probably good. So we'll set that quantity equal to 1. What is going on here?
Does the default have to be the last one?
Yeah, probably does. Yes. Looks like it. I'm not super. So let's do, we'll do a default here then too, just to. make it nice. Okay, so add items, we could switch them around too. It's just not how my brain wants to work this morning. Okay, so adding items into the cart. What's the first thing we should do if we want to add an item into a dictionary?
We should create the tuple variable, I guess.
Okay. So, and this is unpacking a tuple. So we're gonna have, well, okay. What, where are you looking at you want to create the tuple out of this, what we're passing in?
Yeah, just off the top of my head, it seems like you need to either pass in how much they want, and however we're gonna get the cost of that later on, I guess. Then we need to create the tuple, and then you would basically pass in to your cart. It would be what cart dot or cart parentheses name, not parentheses, brackets name, and then equals the tuple. So we need to make the tuple so we can equal the tuple.
Okay.
That's how my head's going.
Yeah, that's exactly what we'll do if there's nothing in the cart already. So what happens if I have something in there that's already the same name?
Are we finalizing? Is that why we're using the tuple?
The tuple is just kind of a handy little data structure to hold this right now. I guess we could have passed it in as a list as well.
But if I recall from the tuple, it's immutable, right?
Correct.
But you can overwrite it.
Oh, okay.
So that's kind of, I guess that's the direction I'm going, because we can take that and make a tuple and just pass it in and add it in, but
Oh, I see where you're going. So basically, if it's in our cart already, then we would need to change the quantity that key in the cart to what we currently have in the add items.
right. So I think the first thing we should do is look and see if it's in our cart already. So if we're getting an apple and we already have an apple in there, then we want to we just want to check and see, do we have this in our cart already? So how would I do that? Does anybody remember? Let's see. Hamilton, are you there?
I am.
Do you know how to check for a key within a dictionary?
Be. I don't remember off the top of my head right now.
Okay. Anybody else?
Do we use dot keys?
We could. What do you mean? Like, do you want to explain further, or?
I don't have the syntax on top of my head, but I was wondering if could we do?
This is the easy way.
Okay.
If we just say, if this is in here, and it'll look through the dictionary and see if that key exists within the dictionary. Okay, so if this key is within this dictionary, we're going to look and see if it's already there. If it is there, what do we want to do here now?
Take the quantity.
Yeah.
How do you update it? Tuple though. This will be interesting to see.
So I liked where we were going first. You said grab the quantity, right?
Yeah, essentially what we're doing, Kim, is we're not going to update the tuple. We're going to replace it.
I know, but it's inside of usually we just do plus equals 1 for the value, but now we have to identify it's the first or second.
Oh, I see what you're
index
saying.
unit.
If you want to add, increase the amount of items, oh, I only wanted 2 shirts. Oh wait, no, I want 3 shirts. So let's just click add items and let's just
Well,
add
no,
one more.
I mean, we usually just plus or minus the value, but now we have to plus or minus the key inside of another value. No, the index inside of a tuple. I've never done that before. That was fun to say.
Yeah. So we're gonna do something. I like the idea is yes, we want to grab what's currently in the cart, right? Because we want to change that, but we don't know how. You can do what's called unpacking the tuple. So we know that our key for each name, we're going to have a tuple of quantity and price. So we can grab our current quantity and our current price is going to be the name. No, it's going to be the self.cart. Like, no, not name. Item. So what this is doing is it's taking that tuple and kind of breaking it into 2 different variables here. We're assigning current quantity to the first part of it, to the quantity, and the current price to the value. So that value at this point, if we call self.cart and pull the value of that item, I want to change it to item. I don't like name. We're thinking of items here. So if we're pulling this item, if we grab this, this should give us something that looks like we have quantity of 1 and a price of like $2.
It's no longer in a tuple though. Each of those variables are assigned a value at that point.
Yes. So here we're saying, okay, take that first one and assign it to current quantity. Take that second part and assign it to current price. So now we can work with the tuple values. So we've got those values. We've got what's in our cart currently. Now, what do we want to do next?
Want to increase the quantity using those values. I guess remake the tuple, increasing those quantities.
Quantity. And we don't care about price, right? For simplicity's sake, we don't. We're not going to care about price. We're going to say it's always the same price. So we can, how would we do this? And this is going to be the only method I'm going to walk through. The rest of them I'll just kind of fly through and we'll just see how these work with our class inheritance, but making y'all think for now. If we want to update this value, we can just assign it a new value, correct?
Yeah, it would be make it into a tuple again, and it'd be current quantity, comma, current price. So
Is it gonna be
essentially replacing it.
current quantity is what we have in the cart. We're passing in a new item here. If we're adding a new item, we're passing in
All right. You gotta add
quantity
it.
here. So we're going to add quantity to it. And then the other part of our tuple is the current price. Okay, so this will reset the value of that item. I'm changing item here too, everywhere, because I keep referring to it as item. And it will rewrite that quantity and price with our new one. Cool. So that is if we have it in the cart already. We need an else. Because what if it's not in the cart? I'll just go ahead for time's sake and say we're just going to assign the value of quantity and cost. Again, I have all the different, we're changing these for consistency's sake because I keep referring it to price. Okay. All right. So that looks good. For good measure here, we're just gonna do a print statement so we can see. Say added quantity by item or yeah, item. Yep. Awesome. So there's our add items. We're going to have our remove items, and I will save time. I actually prepared these earlier, so I'm going to get one here. Remove items is kind of the same thing. We are looking through each item in the dictionary and breaking apart that tuple into something we can work with. We're subtracting the quantity, and if it's less than 0 or equal to 0, we want to actually remove that key from the dictionary completely. So that's what we're doing here in the delete. Otherwise, we'll have, if it's not in there,
What's the benefit of using a tuple over a list? I know tuples are immutable, but wouldn't it make it easier to not have to unpack it?
yeah, we could do that. It was just easiest for me to comma them together.
Okay, I didn't know if there was like some secure, like it helps make it more secure because you can't mess with the tuple unless you go through the method or something.
I mean, that's a good thought, yes. Especially if we're doing like a shopping thing, that could be a reason. Yeah, it was just dealer's choice there for me. Okay, so total cost. This one we're gonna work out together real quick. We'll do this one and then we'll take a break because I see we're getting. Do I need to pass in anything for total cost? I do. Do I? If I call self, remember self can access everything initialized within here.
So it's okay to have a little extra.
So it should, if I call total cost,
Where are we telling it to add all of those though?
well, that's what we're gonna do here.
Oh, okay.
What it would be
I thought you were saying we didn't need it. Okay.
parsing through the dictionary, right? That's all we're doing to get all the costs.
Yep, exactly. So we use this method to add items. So we'll call that to add items, and it's all being stored within this dictionary that is in this class. So in total cost, we don't have to pass in anything to use this method because we have a dictionary sitting there with all our values in it, just waiting to be looked through. So we can just call this method without passing in anything. And here we will basically parse through all of the dictionary items and do a whole quantity times. I'm going to save time because I'm not going to make you figure this out, but I used sum. So I used sum to collectively, add everything together, built-in Python function here that goes through an iterable. And I did quantity times price for each quantity, comma price, and self.cart values. So I just read through all the dictionary values, broke it apart here into these variables. I could then sum together. Okay. And we are going to print. Okay, what's this? Does anybody know what that is? That .2f? Okay. Does anybody remember a data type that begins with the letter F that has to do with numbers?
So doesn't that like I would keep it to
Float.
2 decimal places?
Yes. Okay. So Gizam, you said float. That's correct. And Allison, yes. This one is saying keep it to 2 decimal places within this float. So it's not, it it rounds it to 2 decimal places, but it's not as, I don't think it's as concise as doing like the floor or any of that type of stuff. But this is just for simplicity's sake. We're gonna just keep it to 2 decimal places.
So it's not rounding anything. It's just like if it's beyond 2 decimal places, it won't
It just
take
cuts
those.
it
It
off.
just stops. Okay. It's not going up or down.
I couldn't remember if it actually rounded or not. I would have seen that had I actually printed out a few times, but
Isn't it like a formatting, basically, of your,
yeah. Okay, so checkout. When we check out, again, I don't think I have to pass in anything to call checkout on this cart because we're just looking at all the items we've added in that dictionary. So we can do a checkout self. And this, we're just simulating a feature. We're not actually going to be doing any sort of checkout, but in a checkout, we'll probably want to take the total and do something with it, and then like, clear the cart, right? So we'll go ahead and here we can call total cost. Oops, total.
We all know how to make sure to return the right change.
Yeah, exactly. Oh, so why is this not working? Why can't I do this?
It doesn't need self dot.
Yes.
So
Whenever you're calling any method within a class, always tack on self. Okay, so self.total cost. So if we call checkout, it's going to automatically call total cost and figure out that total cost there. We're going to, let's see. Got all fancy with these F strings, but they take so long to craft. We're going to print out the total. And then after we give them the total, we want the cart to go away. So how can we do that? We want it to be empty again.
just make I'm trying to scroll up on your screen.
Oh, yeah.
Just make self.cart equal an empty dictionary.
Yep. Or we can also clear. Makes it nothing in there. But yes, we can also set it to, as it said, self.cart equals empty dictionary. Okay. Any questions with what we've just gone over in our base class here? Oh, I'm trying to get this down. Sorry. Okay. So we are going to take a break. And when we come back, we're going to start working on the inheritance and working with all these different methods and stuff. So let's take I'm going to pause the video. All right, coming back together, we left off, defined our base class here, just a basic cart where we can add items, remove items, figure out a total cost, and check out. So now we're going to kind of get into the inheritance part, because now I want a cart that we can use for special sales. So I want something, and it's not going to be fancy. It's just going to be everything's 50% off today. So I want to make a cart that will have a discount applied. So okay, we know we want a discount cart. We're going to just set this up. We're going to do a discount cart. Okay. What do we want this discount cart to do?
Should it take a percent of the price? Like have an input be of like for example, if it's like 25% off, somehow incorporate in and input a percent and input up the price and then do a operation inside.
Okay. Yep. So we'll know we'll want a discount for sure. We want to be able to pass in a discount percentage and be able to work with that. So that's definitely something different in this class that we will be doing. Let's set up our init method here. Okay, so we have self and we're going to have a discount because, oh, and do we want, so this cart, do we want it to be standalone? Or I think this cart, we probably want to add items into it too, right? Because this is going to be its own cart that we're using for sales.
So couldn't we just use the template of the other card and inherit it into this one?
Yes, I think that's a good idea. Otherwise, we'd have to set up another empty cart and another add items and remove items. So we want this cart to do the same thing as our base cart. We want to be able to add items into our discount cart and remove items and total cost. That might be where we do something different. We'll think about that, but we also definitely want to check out the same. So I think add items and remove items and the cart initialization itself, we can all inherit. We don't have to define that here. So to do that, we can do, since we're inheriting from cart, it's just one thing. Cart doesn't have any attributes it's taking in, so we don't have to have a parameter defined in our, but we're going to do a super in it, right? We're going to take everything from our parent class here. So we're going to do a super init, and it's going to look at our first class that we pass in, which is cart. And cart doesn't take any parameters, so we don't have to put anything in this initialization method. So just calling this, it's going to say, okay, look at cart and call this initialization method here. So it's going to set up an empty cart for us within this class. Okay. Now we still have discount. Since that isn't in the parent class, we have to define that here. So our discount is going to be what we pass in. Okay, so we're initializing here. Now, we inherit everything from a parent class, so we don't have to do, we can call add items on discount cart, and it'll work the exact same way. We can remove items, but our total cost. What do we want to do here? So we inherit total cost. So we can use total cost within our discount cart. We have to figure out here, remember when we had the same method names within the subclass and the parent class, we could overwrite this total cost method within discount cart. Or to make it easier, we could also define a new method within here that does something different. Do we have any ideas which route we'd want to take?
So basically a new method that would be like discounted cost, and then you would return the total cost method times the discount, right? The percentage of discount.
Yeah.
Because the total cost method returns the total, and then you just want to discount that total anyways.
Yep, exactly. That is a good idea because we could overwrite total cost, but if we wanted to use it further down, like if we made another cart that used discount cart and we wanted to call total cost, then we'd have all that, the naming issues. So I like the idea of just let's name it like apply discount, maybe? Or like you said, what was it, total? Discounted total?
Yeah, discounted cost or whatever.
Yeah. So this will take in self, which is going to be that shopping cart that we inherit from the other class. And now this, how can we apply a discount? So if we just do this and we're not passing in any parameters, how can we apply a discount to our cart? So we know in our base class here, we have a function we can use that will give us a total cost. So we can call that within this function. We can access it because we are inheriting from cart. So we can do, how do we want to do this? So we know our discount is going to be, we'll have to do, our discount total will be, is going to be equal from our total times our discount, right? We already said that. So we can, any ideas?
Couldn't we just return that?
Just return that. So you're saying return. How would I set this?
Just total times, well, as long as the discount comes in at the right, in the right form. Like 80% off, we could take it times 0.8, right? Total times 0.8.
Times
Well,
discount, but
discount, yeah, as long as we make sure the discount is in the right format.
okay, so why can I not get these? What's going on here?
Oh, self, got total self, got discount.
Okay, let's try that. Okay, so discount looks like it's good. That's getting it.
Could we
However,
make total 0 at the very top of the cart? The initial.
Need to call,
Is
don't
it
you need to
total?
call that total cost method that you defined in the previous class?
yeah, so we don't actually have a total yet because we haven't actually called the class to return a total. So we can access it to get a total, but we haven't, so we're saying calling that class. So how do I do that? How can I call the class from a different? I'll tell you. We can refer to our superclass, and similar to what we did here, where we did an initialization, we called the initialization method from our superclass. We can call our total cost. So this will call this method within our class. However, we do need it to be assigned to a variable.
Okay, so you don't say self dot total cost because self refers to the class that you're in. You have to say super dot total cost, so that way it goes into the parent class.
Oh, let's also see, we could probably.
That was one of my questions earlier. I didn't know.
we can do this too because it is inheriting from the parent class, and we will try this in just a minute too. So let's, well, here. Before we do that, let's get some basic cart stuff going on so we can see, well, no, we'll just do it with the discount card. I want to see what this does. Okay, so we're going to initialize a cart, a discount cart. And we're going to see what this is doing. Discount cart equals discount cart. And I don't have to pass it in. No attributes to pass in. Oh. Okay, so we have an empty cart. And I'm going to just borrow in my note here. We're going to add item. And again, I can do this in the Python terminal here, but I'm just adding it here so it's easy to see and it doesn't get lost when we're calling multiple things. Okay. And let's do discount cart dot discount total. Okay, so we expect this to initialize an empty dictionary for our cart because it's borrowing from our parent class here. And we will also use an add item, which we inherit from the parent class to add our item into our dictionary with our quantity and our price. And then we're going to try our discount total, which is calling total cost, which we are assuming we can inherit from the parent class. We've set it to a variable. We're going to do that times the discount we pass in. Oh, we have an issue here. Does anybody see the issue? Let's see.
Yeah, we didn't pass in discount, did we?
Nope, we didn't pass in discount. So we had added this second attribute within this class. So even though cart doesn't take it, discount cart does take a discount. So we will pass in, let's see.
It would have to be a float in order for it to be the math to work, right?
Yeah. So let's try this. So we expect this to set up our cart with a 10% discount.
That'd
And
have to be 0.9.
do
If
it.
we're just going to multiply it, wouldn't it have to multiply by 0.9 to get the 10% discount?
Oh, yeah. So we're gonna have to change this then to different math, I think. So we're gonna have to find the, oh man, somebody help me with the math here. We do the total. So that's gonna give us the total cost, and then we're not gonna do, we need to figure out the discount, right?
Make an
The discount or calculate the amount that it is, like the 80% or 90% instead of 10%. Whichever way is easier, I guess.
Like what total times?
discount and or like
And then
well
minus, yeah, the discount.
And then this would be total minus discount, right? Does that work?
yes, because that's you're taking off the percentage.
Okay. So obviously you don't have to be good at math to do programming. So let's I think this math's right. If not, we'll ignore it and we're just getting the general idea of how we can work with different methods within different classes. Okay, so we expect to add this. Let's make it even so it's not hard for those of us who are mathematically challenged. So we expect this to put in like $4 worth of oranges and $2 worth of mango. So we'll have $6 minus that 60 cents.
That sounds about right.
Okay. Okay. Oh, Yeah, it was even saying that here. So it was white, meaning it couldn't find this. And when we hover over it, doesn't really, okay. It's add items. Yes. Okay. Let's add items, yes. And try again. Trying to this better here. Oh, okay. So who knows? I guess we can print this out. Next time maybe we should add an F string in there. There we go. Perfect. So you can call super or you can call self because we inherited it, as Sean said. Okay, so that is the discount total. Other than that, I don't think we need anything else for a discount cart because we can still call. Okay, so if I do checkout. How can I do the checkout? Let's see. That should be fine. We can just do that. Self dot total cost. Oh, but that won't give us. So we can overwrite checkout if we want.
What if we did total equals total minus discount? Then would it take the total?
Where
Like add another line after 55? It says total equals total minus discount and then return total. And then it's the same word. Would that make that easier?
oh, minus ones.
Would that allow us to use the parent checkout?
Let's see. Okay. No. So we have some problems here because our total, we can overwrite the checkout because this, let's see. We're defining it within this method. This total is not a class attribute. It's just within this method. So we can overwrite another method in here. We can overwrite checkout. We could define a new one that kind of does this discounted total. It does the same thing, but that doesn't sound very dry because I'm doing the same thing essentially, but just wanting, I just have this issue with the total. So what we're going to have to do then is figure out a way to have let's see. Oh my gosh, I'm getting mixed up in my notes here.
Yeah, because we would have to make a new one because it seems like the total would equal the discounted cost now.
Yeah.
And then you want to print out the discounted cost and then clear your cart.
So we can probably.
So yeah, instead of total equals self dot total cost, it would equal self dot discounted cost in our discounted class.
Yep. Let's do that. I didn't even account for this when I was, so we're doing this on the fly. So we're going to do a new checkout just for discount cart. That will take, so we're doing self dot discount total.
Yeah, discount total.
And we'll do that. So now this should take our discount total. Clear this. Which it does, because it overwrites. This might pose a problem for later, but we're going to keep moving on. We will see. Okay, so I think that's good for discount card. It's got all the things we want to do, and it overwrites where we want it to overwrite. So now I want a cart that adds sales tax, because I want to be able to pass in a tax rate dynamically based on different regions and areas. So that's why I'm establishing a separate class for this. Pretty much, I think it's going to be the same thing that we did with discount cart, except instead of a discount total, we'll have a tax total. Sound good? Okay. So we are going to just copy that whole class right here. This is going to be sales cart. We're going to pass in a tax rate, not a discount. Okay, here we're going to not do the discount total, we're going to do a tax total, which is going to be adding it on. So the tax is going to be the total times self.tax rate, and it's going to be plus tax. Okay. And this will be called text. Are we following along so far? Okay. So with this one, if we make a, let's see, tax cart. Helps if it's a different name. Tax card. This one we're passing in a tax rate. And let's do tax card dot tax total. Oh, we have to add some items. Where's my okay, so we have that our tax total. We don't actually even need to call tax total because checkout does that. So we will do our tax cart checkout. Does it look good? We think this is gonna work? Yep. And before, what did I say? Where does its total cost? Where did I put that? Oh, because we put, sorry, it was from the total cost method. I totally lost that in there. Okay, so when it called total cost, then it puts up this total before taxes and discounts or whatever. And then is this right? And then yes, self.tax total calls this, which does the total cost, which multiply in, yeah, looks right. 642. Cool. Okay, so lastly, so these cards, work, we can, again, we're seeing how they can pull into this, reach into this parent class and use these add items and remove items just as if they had it themselves. We've overwritten total cost because we want it to do something a little, or we've overwritten checkout because we wanted to do something a little different. But we are using total cost within these. Again, by calling, we can call within ourselves because we inherit it. And we're using our extra attributes. Any questions before I move on to the final class example? I see faces.
Would you have to inherit the discount card as well? 'Cause I think the total is only getting it from the original cost.
I have
Yes.
a feeling your next class is going to inherit tax cart and discount cart, isn't it?
Exactly. We've kept it
Yeah.
separate just for kind of division of labor and keeping everything within its own little, like, it's best practice to separate out different features, I guess I would say. So if you have a tax feature, you want to keep that within its own class and just call it from other classes if need be. Just to kind of help compartmentalize your logic so that if you do need to change something, it's in one tiny spot instead of sprinkled throughout a whole different area. So that's why we broke it into two separate, because now I can do things with these individually if I want, but I can also do something with them together. Before I move on, was there any other questions before I show combining? No.
Yeah, we could what if it in terms of like what if the discount is applied to it after the taxes are on there, or if it's before, or but I mean I think
Yeah.
just carry on with what you're doing.
Yeah, no, we'll or this is simple example. I don't want to get too much into detail. This is not obviously what we're going to use in a actual website. So general ideas of how you can reach into other classes and use things you've inherited from them. So now the last one we're going to make is a special cart, I guess, for lack of a better name. And this is going to inherit from both, let's see, tax card and discount card. Discount card and tax card. Because I want this special cart to combine kind of discount and tax into one. Okay, so with this one, all I'm looking for is, so I want to be able to add items, remove items, which we do within the original class because we're inheriting from discount cart, but discount cart inherits from cart. So we get all of these methods we've defined within here. But we want, instead of, we'll do a checkout again. So I like the total cost because I do want a total cost of all the items so we can reuse this method. But when I go to checkout, I want to see both tax and a discount applied. So with this one, we're inheriting from both. Let's do our initialize. You start off always with your init method. Oh, look, VS Code is so smart. It already pulled in discount from discount cart because it saw that I was inheriting from discount cart. I just pushed tab and it already did my super init. So here's where we run into the issue. I need a discount and tax. And we touched on this in lecture. If I do this init with discount, it can only pull discount because that's all discount cart has. If I try to add in tax, it's going to freak out because it doesn't, discount cart doesn't have it, and it won't, the super init is only looking in discount cart because it only uses the first class. So if I want to get this tax, we're going to change this. We're not just going to do super. We're not going to call just this parent class here by super. We're going to explicitly call discount cart's initialization to get the discount. And then to get the tax, I'm going to call tax carts in it. Get the tax. And let's see. So what it'll do is it'll look, so we went to discount cart first to grab the discount, which looks in here and it says, okay, we've got discount, and it pulls discount. We don't have I just realized we don't have a default value. So good practice is to put a default value just in case nothing's passed in, so you could still have everything working. We'll do that now. Let's do a discount of 0. Just in case. And then same with tax. We don't have a default value. Let's put 1. But this looks in discount, grabs setting up our discount attribute in discount cart. And this looks in tax and grabs how we, it's called tax rate. Has to be the same name, because if I look for tax, it's not going to find that. Okay, so has to be tax rate, because that is what this one is initialized with, is tax rate. Okay. Should be all I need, right? Do I need to define any new attributes for this? All I want to do is find a new total, like, or check out with a new total with a discount and a tax applied. So do we need to add any other attributes, or we think we're good? Oh, we're gonna catch this here. I should have made y'all catch that, but that's okay. You need to have pass and sell first, always. I would forget until I run this, and then it throws errors and issues, but always self after your init. And any method, we're always passing in self, because we want it to work on our empty dictionary that's filling with items. Okay. So now we got that. We have our add items. We can add items, remove items. How do we want to go about doing a new checkout? Do we want a new checkout, or do we want a new total cost? What seems the best route here? It's kind of, your choice, what you want to do. I think I want to use the total cost method I've already defined, because I don't want to have to write it again. So I think I'm just going to create a new checkout method. Okay. Oh, sorry if you can hear my kid crying in the background. Okay, so we're going to overwrite our checkout method. What is that doing? That filled it in automatically. So what this is doing is it's just saying use the parent checkout method, like use the checkout we've defined. Well, okay, it wouldn't use that one because it's going to look here first. Super means it's going to go to the first class we've called in here to inherit from. So it's going to use discount carts checkout method. I don't want that. That's not what I want to do. So with this one, we're going to have our total is going to equal, let's do final total. It's going to equal a total minus discounts plus taxes. Okay. So we've already seen before, we can get our total by calling our self dot. What is it? Total cost? See, now we're getting so many methods, it's hard to keep track. It's total cost, right? Yes. Okay.
You cannot call super twice to reach the parent of the parent, right? There's no such syntax.
I have not seen that. I'd have to look into it. I don't like you're saying maybe like that, which it doesn't look like it likes. So I wouldn't expect to be able to string
Yeah.
together like that.
Yeah, that's what I meant.
Yeah. Also because if you just do the dot, it's gonna call a method within this super class. So super is its own thing. Or super, it's not a class, is it? It is a class. Why isn't it uppercase? That's gonna mess me up. Classes usually start with an uppercase letter, so I'd have to look into why super is special and doesn't have an uppercase. But yeah, that's a good question. The way it works is it literally super is just taking that first class that's passed in. And I'd have to do some more. Do y'all know how to look at like built-in methods or in classes within Python? Do you know how to navigate to this to look at it more? Like this. If you control click, and this is kind of, you guys had an assignment like this before. This is a good segue into showing you this. Anything that you hover over, you can push control and see if it's clickable, and it'll go to where it's defined. So here, this is defined here, so it just brought me here. But this super is a built-in Python method, so I was able to control and look at it, and here is the class, super, with all the things that it has associated with it. But that's useful for stepping through code because also I can come here and do this total cost and it brings me to where it's initially defined. So kind of handy. That's control left click in VS Code. It helps you step through pre-existing code. And it'll bring it, it's not only in the same document, it'll bring it. So we could also do that within it. Oh, no, we can't. You can just click around and see. That brought me to there. Total cost brings me back up here. So anyways, yes, just a little side note. So we're doing total cost. Oh, that was from looking at super. So, okay. Total cost. I'm getting back on track here. Okay, and then we want to do we'll do it in steps. So we'll do a discounted total. And we can just do, I guess, total. Well, we're going to have to do, we can call discount total. So we don't even have to do the discounted total. Okay. I'm kind of thinking through the math here as I go. I'm not sure where I'm going with this, but I know we can call discounted total to give us a discount total. So that kind of makes this. How is this going to work? Can anybody think about the math of this?
Yeah, I mean, we're gonna have to, with how taxes and discounts go, we have to get the total, the discounted total in a variable, and then we have to apply the taxes to that. But how we have the classes set up, they're their own total costs coming out, and you don't pass any variables into them.
Yes. Okay. So I knew we would get to this point because yes, we're overwriting stuff and we're turning new values, but this isn't very, instead of a tax total, I wish I could do like a apply tax. You know, I want to apply tax to some total, right? That seems like a little bit more
Yeah.
realistic approach.
Yeah, passing into some total into basically a calculator in a sense.
Yep, exactly. So we can do that. We can just pass in, we can say, I want to pass in a total, and then this would be what, return. Did all this math beforehand.
Yeah, it'd be like the tax amount would be the total equals the total or taxed equals total times the tax amount, which would be a float.
Okay. And
Then you just subtract that from your total.
taxed total equals total minus tax. And that we want to return the tax total. Okay. Awesome. And let's do a string so we can see what's going on here. Always good to have some logging in the console. Okay, so I like this better because I want to pass in some total. So yeah, let's just leave that right now. I'm going to comment these out so they don't, because these are using tax total here. So let's work with this. Okay, we'll start with the tax then, since that's what I did first. So taxed or apply taxes. How am I going to call that? This is going to be apply. We want to apply taxes. Okay, so we have the total, which we just set up here. We have a total cost because we've used our parent class total cost that we've inherited. So we have a total. So since I've inherited everything from discount cart and tax cart, looking at tax cart, it looks like I can use a method that takes in a total, right? So theoretically then I should just be able to call, let's do slide. I should just be able to call apply tax on the total we just defined here. Right? So it's kind of weird setting up a method here that doesn't necessarily, like, you're sitting, where's this total going to come from? You don't see it in this class anywhere per se, but you know you want to be able to give it a total to apply a tax to. So it's just kind of a placeholder for you to work with. And in this one, we're actually, you can see we've defined a variable to pass in as the total. Are we following with that? So with the discount, we could do the same thing. Instead of doing a discount total.
I was gonna say, you could probably just keep that and then just pass in the discounted total if you want to keep it to how they apply discounts to taxes to discounted items.
So
you would, yeah.
Okay, let's do this then. Oh,
if you don't mind humoring me for a second.
Yeah, no, let's do it. Let's
yeah, go down to your what you were trying to do just now. And then see here, taxes applied total equal, you're calling the applied tax, and then pass in that method, self dot discounted total.
In here?
Yeah. Can you pass a method within there, or do we have to get it in a variable first? So that self dot discounted total should be the discounted price of the total, correct?
let's look. Let's shift click, discount
And then you're
total.
applying the tax to that total itself, because that's generally how they apply taxes to discounted items, because they do it after it's been discounted.
Yes. Yep, so I'm looking here and making sure this does return a number, a value, a total. So this, you see, we don't actually return anything. So if I were to try to call this within something, it wouldn't behave well. But this does return a total. So this total will become what we plug into apply tax. So we throw in a total here, and it's going to do this calculation on that total and return out the tax total. So now that we've got that tax total with that discount, so apply taxes on a discounted total. And this is our checkout feature. So we've defined it as a checkout feature, but actually now that I'm looking at it, let's look at our checkout here. Yeah, it's because we stuck in this. If we had put this anywhere else, maybe. But because we've defined total cost, we can't use this anywhere else that we get a total value. So yes, we'll keep overwriting the checkout feature. So this, and then we're going to just print out the result. We named it something different than I did. Okay, and then we will turn tax applied total. Okay, so with this card, should be able to do all the same things as this one. We should be able to, let's see, special card, and this is going to be a special card. Now we need to pass in, we can either explicitly define the attributes we're passing in, so we can say discount equals and then the discount, or as long as you pass it in the correct order, it'll plug it in the spot it needs to go in. Gets confusing though if you have a ton of attributes, so sometimes it's a better route to do explicitly define like this. So that discount cart takes in, or special cart takes in a discount and a tax rate. Okay, it's going to set up our cart as defined in other classes. We're going to add items because we can do that here. Okay, and then we should be able to special cart dot checkout. And this should give us our total with the discount clears. So it's easier to see. Oh, let's see, what do we got going on here? Discount cart takes in 1 to 2 positional arguments, but 3 were given. Discount cart. On which line? Special cart equals, so it's passing in here. Trying to see if I see anything wrong with this.
Is that because name is not in there or something?
So discount cart,
Because
it's
three word.
I think my init is not working as it's supposed to. We've done discount, tax rate. Done that.
What if you removed self from within the init call, since you had the object up front, or the next line?
This one. Just do that. Let's see. I might have to look into this a bit. Tax card. So let's do the same thing with tax. Maybe that's it. Trying to see. Of course, my other inits don't have anything being passed in. Just gonna look at an example. Special has no attribute card.
You're actually creating the items here because you're calling the special card function, but it's getting discounts and tax rates. But where is it getting the item name, item amount, and the quantity? How is that created?
So that should be created from when we use discount cart, which inherits from cart. So it's pulling everything, when we inherit from discount cart, it's pulling everything from here, but it's also, here, let me pull this down. Also pulling everything from cart, which we're doing here. So all we've defined in cart is an empty dictionary. Our add items method is what is adding all these item, quantity, price. Does that make sense? So we don't have to, these adding items are not something we're setting up in every cart. We just want an empty dictionary. That's what every cart gets right away, is an empty dictionary. But then we add items to the dictionary using this method. We could potentially put some placeholders in here, but I think for this scenario that doesn't quite make sense because we don't want anything in that cart initially. But we could definitely have our cart be a dictionary with values in it already.
It doesn't seem like in our error down there that special cart is reaching cart.
Yeah, I think there's something wrong with my init. This was supposed to work, but I don't think it's working as it should. Let's do... What's the discount? I'm wondering if we can just do tax part in it now. We can see if that works. Yes, because this error is definitely telling us that it's not reaching into the parent. That worked. Maybe not. So it worked, but I don't know if it's getting the tax applied. Yeah, this just used, so it's not complaining anymore, but that just used the checkout from discount cart. I'm gonna pause the recording for a bit here. Okay, so back recording, when we figured out that you don't put parentheses like you do super, you just access the class. That makes sense. I don't know why I put parentheses on there, but yes, you're accessing the class's initialization methods here. Okay, so the reason I'm looking back at our curriculum here. The reason why this worked here when we did not do all these crazy initializations with different classes is because we were only pulling name from the parent classes. So name exists in both vocalist and guitarist. So it
But
doesn't have an issue.
It's only pulling it from the first one, though, vocalist, though, right? It's like, okay, it's right there.
Yes, yeah, yeah. It's coming from here. If we were to put Mike in this init, it would have an issue like we encountered. So that's why this one's kind of getting around that by redefining. So we could do that in ours instead of calling, I don't know if we can in ours. Let's see. We could. So what we could do is instead of initializing from the parent classes like that, we could literally just do and just reinitialize here within this class. So then we wouldn't need this. It would still inherit all the methods from discount cart. You don't have to worry about that. That will still inherit. But we'll have to do a super to inherit a super in it. Beforehand here. We're gonna see if this works. Because that's what the lecture did. Okay, so this is saying initialize this object with this plugged in as discount and this is tax rate. We're still going to superinit. I don't necessarily think this is gonna, we'll see. I don't know if that's gonna grab the tax one. No, it did. It worked. Okay. Superinit will grab all of them. I guess just the attributes are only limited to that first class.
All right, so it grabs all methods.
Yes.
It's the variables.
Yes. And that's what we saw in lecture. We were able to call the different methods from these classes with the super init. We didn't have to explicitly define which initialization we were using. We just did one super. It's only for the sake of the attributes that we have to be careful about how we're passing down or where we're defining. Okay. After that little hiccup in discovery, are there any questions there? No? Okay. Probably didn't need, I wonder which one's doing bad. If you do your own thing, clean it up. Make sure you're not shooting out multiple F strings that say the same thing. Make sure you clean it up so it's drier than this, but this was purely just an example of how we're able to reach into the other classes. So yes, we could do it like this, where we initialize these variables again so that we don't, or we could reach into the classes and use their initialization methods. Okay. That is it for a really long lecture today. I'm sorry. I'm gonna stop the lecture now.